Hi everyone, welcome to the video. My name is Dirga Palit and today I am going to explain the concept of hashing in data structures. Hashing is a technique used to store and retrieve data efficiently using a special function called a hash function. It is widely used in many applications such as databases, caches and password storage systems. What is hashing? Hashing is a technique that converts data into unique index values. The index tells us where the data should be stored in a table, which is called a hash table. The main advantage of hashing is fast access. Instead of searching through all elements one by one, the system directly goes to the location where the data is stored. Because of this, the average search time is using hashing is big O of 1, that is, the time complexity of search is constant. Hash function. A hash function is a function that converts a key into an index of a hash table. For example, suppose we use the function h of k is equal to k mod 10. There can be similar many functions which are be used as hash functions. Now this slide shows the hash table along with examples of how hashing works. A hash table is a data structure that stores data using index positions. Each position in the table has a specific index number. When we insert a value, the key is passed through the hash function, which calculates the index where the data should be stored. For example, if the key is 25 and the hash function is k mod 10, then 25 mod 10 equals 5. So the value will be stored at index 5 in the hash table. Similarly, if the key is 37 and the hash function gives index 7, so the value is stored at position 7. So hashing helps us directly map keys to position in the table, which makes data storage and retrieval very fast. Collision in handling. A collision occurs when two different keys produce the same index value. For example, if the hash function is k mod 10, the key 15 gives index 5 and the key 25 also gives index 5. Both values want to be stored at the same position in the hash table. This situation is called a collision and we need special techniques to handle it. Handling collisions and applications. First, going to applications, hashing is used in many real-world applications such as database indexing for fast searching, password storage systems, cache memory in computers, symbol tables in compilers. Now coming to handling collisions, to resolve collision we use different techniques such as chaining and open addressing. Because of its speed and efficiency, hashing is widely used in many computer systems. Now let's see the different types of collision handling techniques. First comes chaining, also called as separate chaining. It is one of the method used to handle collisions. In this method, each index of the hash table contains a linked list. If multiple keys generate the same index, they are stored as a linked list at that position. For example, if the keys 15, 25 and 35 all produce index 5 according to the hash function we saw earlier, which is h of k is equal to k mod 10. They will be stored as a chain of element at index 5. Next comes open addressing. This is another technique used to resolve collision. In this method, instead of storing elements in a linked list, the system or the algorithm searches for the next available empty slot in the hash table. If the calculated index is already occupied, then the algorithm checks another position until an empty slot is found. Some common techniques used in addressing are linear probing. Linear probing is where the next slot after the collision occurs is identified. The next slot is free or not. It checks if the next slot is free, then the data is stored in that one. Otherwise, it goes for the next one. That is, if the index is 5, then 5 plus 1. If 5 plus 1, which is 6, the sixth index is occupied, then the data is stored in the index 6. Otherwise it goes for 5 plus 2, which is 7. It checks one by one, so on. Next comes quadratic probing. Quadratic probing is where it goes one by one. It checks the next empty slot by squaring the number. That is, if the index is 5, then 5 plus 1 square, which is 6. If 6 is empty, then data is stored in the 6th index. Otherwise it goes for the next one, which is 5 plus 2 square, which is 5 plus 4. So the 9th index, if the data is stored in 9th index already, then it checks for the next one. Otherwise the data is stored in the 9th index. Next and finally comes double hashing. Now double hashing uses another hashing function from the already existing hashing table to store the collision occurring data in the second hash table using the second hash function. Finally, coming to conclusion, hashing is a powerful technique used to store and retrieve data efficiently. It converts keys into index position using a hash function, allowing very fast access to information. Even when collisions occur, techniques like chaining and open addressing help manage them effectively. Because of this efficiency, hashing is widely used in many real-world applications. Thank you for watching the video.